All right, Algebra 2, we are going to jump to 7.3. We're going to start talking about logarithmic functions. What's a logarithmic function? They are inverses of exponentials. So all the exponent stuff that we've done this year, we're going to flip it around. Okay, what are inverses? All right, addition, subtraction, inverses. Square roots, inverses. So exponential and log functions are going to be inverses as well. All right, and he's saying, wait a minute, we skipped over a section. Yes, 7.2. 7.2 introduces you to a little equation called PERT. Okay, this is for investments or exponential growth, and that's what we deal with. So the principal amount that we're going to end up with equals the E. So that's a number. Okay, so if you check your calculator around the natural log buttons, you're going to see an E on there, and it's going to be to the power of the rate and the time as decimals for the rate and time. So we deal a little bit with exponentials so far, so we have that. And it's going to be around 2.71. Where do I categorize this number in my brain? It's going to be something like pi. Okay, it's non-terminating, non-repeating decimal. So that's basically the whole section. We can circle back, do some investments with it. But this year doesn't allow for the time at that point. So let's see what we do with it. All right, so we're going to take this exponential equation, right? 5 to the second power is 25. We'll agree with that, right? So this is the base to some power equals 25. And I'm going to go straight to, here's the next thing. Here's what we're going to work on. All right, log base b of x equals y, right? That's how we say it. Log base b of x equals y. And I get a little easy way to remember this one, right? So log starts with L. So we're going to make this L shape. And that should be whatever is going on in your base with an exponent. So here's what it looks like. Okay, so just watch me write this one time. So log equals. So here's what I want. I'm going to draw this on for the first few times. Then we're going to stop doing that. So you see a big old L shape? Now in that L shape, I have to make sure I put in this base 5 to the second power. So my leftover number has to be 25. So we're saying log base 5 of 25 is 2. Now, how's that work? We're saying, well, how many 5s, right? If I count by multiples of 5, do I need to get 25? Well, that's 2. So that's how it works. Okay, so we do need true equations to get started with, right? So 5 cubed is 125, 6 cubed is 216. So here we go. Let me go. Same color pattern here. Log equals. All right, so the next thing I want to do is draw this L-shaped box in here. I'm going to make it a little bit taller because I got fractions. So that means down here should be 5/6. 5/6 to the third power equals 125 over 216. Okay, so we're going to simply just use that L-shaped box, and that's how we get the chance to rearrange those. All right. We're going to write each one in log form. Notice I have it turned around, but it really shouldn't matter. So log, little space, equals. Okay, so I need to have this in here. So 6 squared gives me 36. Log. So at some point, you can stop writing the L-shaped box when you get comfortable. Okay, so my base should be the subscript. 2/3 to what power? That equals 3. And it's equal to 8/27. Okay, so working kind of in that circle. All right, so one thing that throws kids off is the idea of anything to the 0 power gives me 1. So let's see what it looks like. So log base 3 of 0 equals 1 as I work back around. Okay, so if I'm trying to get log 1, right, so that kind of works in a circle. So 3 to the 0 power gives me 1. So you'll see when we start to evaluate, you'll be like, hold on, that can't be right. All right, let's get into the next one here because this one has an interesting extra step going on. So we want to evaluate this, right? And yeah, there's a log button on my calculator, but it only works with log base 10. Now, some of the newer ones, you can change the script on it as well. But here's what happens. So it's log base 8 of 32 equals one of these numbers. Okay, so here's the first thing I'm going to do is I'm going to go ahead and rewrite it. Then I'm going to change it. I'm going to change it. So we're going to draw that L-shaped box. So I have 8 to what power gives me 32? Well, I don't know. 8 squared is 64, but it's not that. So what I have to do is I have to write these both with the same base. So 8, we would agree, is 2 to the third power. So I'm going to write that as 2 to the 3x. All right, so that's 2 times 2 times 2 gives me 8. Times 2 again is 16. Times 2 one more time gives me 32. So I'm able to write both of these, 8 and 32, with the same base number. So now I get to drop the base. So we're going to solve this. 3x equals 5, divide by 3. Look at that. That means if I took 8 to the 5/3 power, I would get 32. So 5/3 is my answer. If you don't believe me, put it in your calculator. But why wouldn't you believe me? Seriously, we've been doing a lot of work together, and I'm going to play like that? Jeez. So for these, I'm going to draw equals x, right? Because it says, what is the value? I'm trying to evaluate what it is. So 5 to what power gives me 125? 5 times 5 is 25. Now I got 5 quarters. That's so 5 to the third, drop them. There we go. All right, so that one's kind of nice because I don't have to change both the bases. But the next one, this one gets a little hairy again. All right, so 4 to what power gives me 32? Well, 4 times 4 is 16, and times 4 again is 64. So this is not going to work out as nicely. That means I want to change the bases, right? That's the common question. If we were in class together, you'd say, how do I know when I have to change the bases? If I can't turn 4 directly into 32 by using powers, then I have to change the bases. So we're going to go 2 squared. Quiet down. And we're going to go 2. We just said 32 was what? The 5th power. Okay, so now we're going to drop those. So 2x equals 5, divide by 2. So 5 halves. Don't believe me? Plug it in. 4 to the 5 halves power equals 32 on your calculator. Okay. All right, here we go. One more. This one, just careful with this one. Notice it's 64 to what power gives me 1 over 32. Man, what's going on with that? Now again, 32, that's not a perfect power of 8. It's not a perfect power of 4. So these are all going back down to 2. So 64 is actually going to be 2 to the 6x. And 32 is 2 to the 5th power. But notice what happened? This is a fraction. So that means it's going to have a negative exponent. That's how we flip those around. So now we're going to drop those. 6x equals negative 5. Divide by 6. So negative 5, 6. So I know that because I'm going from what looks like a whole number, 64, and I need to flip it over. So it definitely has to have that negative. And also the fact that I'm going from 64 into 32, right? The negative flips it over. So 64 to 32, I want to make sure that I have a proper fraction. Okay. I'm going from 4 to 32. I'm trying to get larger. So I want an improper fraction. I'm going from 5 to 125. I want a proper fraction. And that one works out really nice. Okay, so we'll point out some of those. So I look at this one, 8 to 32. Well, we're getting larger than the base, so I need an improper fraction. So we want to have some idea, some number sense of what's going on. All right, your calculator, if you got the normal calculator, they work with base 10. Okay, so that means it always says log base 10, like it says right here. Okay, so if I write it without a base, that means base 10. And that's what it says on your calculator, right? So if you forget, check out your calculator. It'll say log of something, and then in your second function above it, it says 10 to the x power. So there's a constant reminder right there in front of you if you forget. All right. The next thing we have to do is graph it. And we actually never graph the log function. What we do is we find out the exponential function. So that one here in red. Okay, so if I plug in 0, I get 1. If I plug in 1, I get 10. If I plug in negative 1, I get 1/10. And then what I do is, since they're inverses, I'm going to simply flip-flop all those points. So y equals 10 to the x power. And that gave me xy. We said 0, 1. We said negative 1 gave me 1/10. And we said 1 gives me 10. So when I go to do the log function, I go through and I say 1/10 will give me -1. 1 will give me 0, and 10 will give me 1. Okay, so we're simply going to inverse all those points. And then that's how we graph the log function. So this one turned out to be the one in blue. Right, 10 gives me 1 way over here. 1, 0. And 1/10 gives me -1. Okay, so that's right about there. All right, so if I ask you to graph something, you're always going to use the exponential. So here's my exponential table. Okay, that is located in red here. Okay, so 0, 1, 1, 3. So I'll point out some of those. Okay, and we know -1 is that 1/3. And then what we're going to do is flip-flop them. Okay, so the only ones that I get flip-flopped, 0, 1, 1, 3. Okay, now I have to know what's going on because here's the next thing is I cannot do log of a negative number. Okay, so that is a no solution, right? It's undefined. Notice that's going on here. So we cannot do log of a negative as we get into our log functions. All right, last thing we have to do is translate the graph then. So it just says, how does it go? Okay, so we want to make sure that anything inside is going to move it left and right and its opposite. Anything outside is up and down and true. And remember, if I multiply it by a number in front, okay, that's either going to make it a stretch or it's going to compress it. It could also flip it over if we make it negative. So those are the things we're going to deal with. So if it says x minus 3 on the inside, that's actually going to be right 3. Plus 4 is going to make it move up 4. So I would start by using 2 to the x power, inverse those points, and then move those points right 3 and up 4. Okay, same thing in b. If I needed to graph it, I would start with 2 to the x. I would inverse those points. And then since it's multiplied by 5, right, that's a vertical stretch of 5. Okay, so I would multiply and move all those up 5. Okay, so that gives us enough to work on at this point, right? So we're going to rewrite it. We're going to evaluate. Notice I did equals x right here. So 2 to what power gives me 16. We're going to graph it. These go in pairs. These go in pairs. And then eventually describe. So you're just going to say left, right, up, down with these. And that'll work if you're in my class. If you're not in my class and you're like, dude, I'm not doing your homework. All right. So I have these laid out with a little more space to the right. And we'll keep plugging away at log functions.